Today I'll talk about mass and energy balance for two heated tank. Now here is the problem statement. The system consists of two perfectly mixed tank in series with oil flowing at a constant rate. The density rho and heat capacity Cp of the oil are constant. The volumes of the tanks are V1 and V2 respectively. The oil entered the first tank at temperature T0 and the flow rate is F0 and density is rho 0 here. A heating coil in the first tank add heat at a rate Q1. So this is the adding heat Q1. Now objective is to derive and simplify the mass and energy balance equation for both tank under this condition. So this is tank 1 and this is tank 2. Now the tank 1, that oil is flowing at a volumetric flow rate F0, density is rho 0 and temperature T0, and that oil is coming out from the tank, the volumetric flow rate F1, temperature is T1 and density rho 1, and tank 2, that volumetric flow rate is okay, F1, T1 and rho, volumetric flow rate F1 and temperature T1 and rho 1 is the density, and coming out from the tank 2, volumetric flow rate is F2, temperature is T2 and density rho 2, and tank 1 volume is V1 and tank 2 volume is V2. Now here first we have to do mass balance for tank 1. So mass balance term for tank 1. So general mass balance for tank 1 can be expressed as accumulation of mass is equal to mass inflow minus mass outflow. So for tank 1, accumulation of mass is nothing but d dt of rho V1. So rho is the density, V1 is the volume of the tank. So mass inflow is rho into F, actually rho 0 V1, okay, and mass flow out is rho 0, again this is F1. So here since the system is at steady state, so there is no accumulation, so rho F0 and rho F1, rho F0 is equal to rho F1 because d dt of rho V1 is actually 0 because it is steady state. So rho F0 is equal to rho F1. So we can write, so F0 is equal to F1. Now if I do that energy balance, so energy balance term for tank 1, so energy balance of tank 1 is given by accumulation of energy is equal to energy inflow minus energy outflow plus heat added. So for tank 1, accumulation of energy is d dt of rho Cp V1 into T1, so mCp dt, so rho V1 m Cp and T1 T, d dt of rho Cp V1 T1. So energy inflow is, so whatever F0 actually T0 and this is F1 T1, so rho Cp F1 T1. We know that F0 is equal to F1 is equal to F. So that's why rho Cp F0 T0, that is energy inflow, and energy outflow rho Cp F1 T1, and heat added, that is Q1. So now energy balance, if we plug all this term in that equation, so energy balance equation is then d dt of rho Cp V1 T1 is equal to rho Cp F T0 minus T1 plus Q. So this is the tank 1 energy balance. Now if I talk about tank 2 mass balance, so again accumulation of mass is equal to mass inflow plus mass outflow. Here no chemical reaction is happening, no chemical reaction, so heat mass generation and consumption is 0, no chemical reaction, so mass consumption and generation is 0. So accumulation of mass is equal to mass inflow minus mass outflow. So now we have to calculate each and every term. So d rho V2 dt, so this is F1 and this is F2. So here at steady state, so this term will be 0. So you can write rho F1 is equal to rho F2. So F1 is equal to F2 is equal to F. So here we can write F0 is equal to F1 is equal to F2 is equal to F. And we already in problem statement, rho is constant and Cp is also constant. Now, so energy balance for tank 2, accumulation of energy is equal to energy inflow minus energy outflow. So here no heat adding or no heat taking out. so there is no heat generation or consumption term. So now accumulation of energy is again ddt of rho Cp V2 into T2. So V2 is the tank volume and T2 is the temperature inside the liquid. Energy inflow is rho Cp F T1. So this is the energy inflow, and energy outflow rho Cp F T2. So now if I plug all this, so ddt of rho Cp V2 T2 is equal to rho Cp F T1 is equal to T2. Now we got energy balance and mass balance. So now if we simplify that equation for tank 1, so rho Cp V1, so these all term are constant. So d capital T1 by dt is equal to rho Cp F T0 minus T1 plus Q1. So this is the energy balance for tank 1. And similarly the simplified energy balance equation for tank 2, so rho Cp V2 dt2 by dt is equal to rho Cp F T1 minus T2. So that is the energy balance for tank 2. That's it. Thank you.